everyone, this is my fifth video for the Sparks Foundation GRIP program. This one is going to be on traffic sign recognition. So the dataset I got was the German traffic sign uh, recognition image set. This is available on Kaggle, and Kaggle is where I ran this notebook and downloaded it later. The dataset was too big for me to download and work with it. It would have taken too much time. The first thing you do is import the essential libraries. I have I've moved the import of these Keras and TensorFlow libraries here as well. So the OS was just to get the necessary data. NumPy and Matplotlib, as you all know, are for data handling. Model selection for train and test split. We have Keras processing for the image. This is going to be a new one. We have the image data generator, image to array, array to image, and load image functions. Next, we also have two categorical values and a convolution, max pool, dense, flatten, dropout, and a sequential model. These things you have seen in the previous videos. So the first thing, we got the directory of the data, the path to the train, the path to the test, and what we wanted the image height and image width to be. You could increase these values. The only thing it would result in is taking too much time to train, and of course better results as well. But I just decided to go with 30. We have 43 categories, and you can see these are the 43 categories that are available. We have the speed limit signs, left turn, right turn, traffic light, speed bump, I think, and a few others. So next we have load data. This was a function to load data to take the image from this. All is just to get the image and categories from the path that was provided. We have a target size, which was image width and image height, so it's going to be a 30 by 30 cross 30 image. We add the image to the images list, and we add the labels to the labels list, the category to the labels list, and return it here. The labels are then converted to categorical data. I explained why I did that in the last video. We then split it into a training and test split. We create the sequential model. We add the first convolution layer, convolution 2D, max pool 2D, and then a dropout. So basically taking that kernel size, using the filters, and basically lowering the dimension of the data while maintaining the information that the data has. We have a second convolution layer and finally a third convolution layer. This is all the convolutional part of the model. I had forgotten to write a model.summary, so here it is included. You can see that there are these many of parameters in each layer, so these are the total number of parameters that can be trained. We hadn't flattened it yet, so we flatten it, use a dense layer, then from 64 units we bring it down to 43, which is the number of categories which are going to be categorical, and this is how the model finally looks like. We're going to use categorical cross entropy like for Adam optimizer and accuracy metrics. I ran it for 30 epochs with the validation data as X test and Y test. You could as well just not use the train test split and use a validation split of 0.1, 0.2 or something like that. We have 60 steps per epoch, and after it stopped running, we had an accuracy of 97% and a validation accuracy of 98%. Yeah, so the test set accuracy was 98.57. We can plot the accuracy and training loss. This I did not do in the last video. As you can see, as the epochs increase, the training and validation accuracy increase and the loss decreases, they converge. This is just to further look into the accuracy using the class ID and path. We get the labels that are true and we get the labels that the model predicted. and we test the accuracy. It's 94.38%. So from the predicted um, images, we take some of them and we plotted a few of them here with the actual prediction and the predicted category of the image. As you can see, the model has done a pretty good job. Here we see in red where the image was classified wrongly. As you can see here also, you can see there is an image that was not classified correctly. Yeah, so this was all to this model. I'll see you guys in the next video.